Lately, y'all have been asking me, what is the difference between a postulate and a theorem and a converse? And I discussed some of that with some of you, but a postulate is something that is taken without proof. It's like a definition. It is a statement or a reason that we just understand to be true. A theorem is something that needs to be proven. And often with theorems, there are converses to the theorems, relating back to Unit 2, where we learned about a conditional statement and the converse of the conditional statement. Well, a corollary to a theorem is simply a statement that can be proved easily using that theorem. So now we want to talk about the corollary to the triangle sum theorem. So recall from 5 minutes ago that our triangle sum theorem says that the interior angles of a triangle sum to 180 degrees. The corollary to that is that the acute angles of a right triangle are complementary. So what does that mean? That means that the acute angles of a right triangle sum to 90 degrees. So that means in triangle ABC, I can see that the measure of angle A plus the measure of angle B has to equal 90 degrees. I already know that C is 90 degrees. These two, A and B, need to sum to 90 degrees. All right, let's look at example 3. The front face of the wheelchair ramp shows a right triangle. So they've just told me that this is a right triangle. So I would go ahead and mark this so I don't forget. The measure of one acute angle is 8 times the measure of the other acute angle. So I've got two angles, and one of them is x. We'll make it that one. And the other one is 8 times that. So 8x. And we want to find the measure of each one of those angles. Well, if I know this is a right angle, the corollary to my triangle sum theorem tells me that these two angles must be complementary, which means that 8x plus x must equal 90. So then I know that x must be 10. So there's one of my angle measures, 10 degrees. And my other angle measure is going to be 80 degrees. All right, so now it's your turn to practice. Go ahead and pause the video, try the problems below, and then come back and get the answers to double check. All right, so in the top, angle 1 is 50, angle 2 is 130, angle 3 is 50, angle 4 is 130, angle 5 is 40, and angle 6 is 30. In the bottom 4, x is 43, y is 32, x is 85, y is 65, x is 35, y is 3, x is 62, y is 28. So if you have any questions on any of those, just make sure you ask me the next time I see you for a clarification. All right, now it is time for the best part of the day. It is time for proofs. So we're going to prove a couple of things that we talked about today. And the first thing I want to prove is our triangle sum theorem. Now, sometimes when you're trying to prove a theorem, you may need to add a line or a segment or a ray to the diagram that you've been given. And in order to prove our triangle sum theorem, we have to use what we call an auxiliary line to actually solve our proof. So the first thing we want to do is we want to draw an auxiliary line through point B that is parallel to AC. So we haven't really been given anything except this triangle. And I want to draw BD so it's parallel to AC. Now I know I can do that because of my parallel postulate. I know that when I have a point and a line, that there is only one line through that point that will be parallel to my other line. So I am drawing line BD so that it is parallel to AC. So that's my auxiliary line. So then the next thing I want to do is I want to think about, what does that do? When I draw that line, it creates two more angles. I have angle 2, that's on the inside of my triangle. But I also now have angle 4 and angle 5. And I know that BD is a straight angle. So therefore, I know that when I add these three angles together, they should equal 180. Therefore, the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 equals 180 degrees. That's our angle addition postulate, because I know I can add the three angles together. But it's also the definition of a straight angle, understanding that a straight angle is 180 degrees. Next, angle 1 and angle 4 are congruent. Well, what kind of angles are angle 1 and angle 4? They're in between the two parallel lines, and they are cut by this transversal AB. So that makes them alternate interior angles. And then if you look at 3 and 5, same parallel lines, different transversal, they are also alternate interior angles. Now, we talked a little bit about the difference between congruent and equal. And if my angles are congruent, that means my measures are equal because of the definition of congruent angles. And if my measures are equal, then that means I can substitute angle 1 where I had angle 4. Up here, I had the measure of angle 4, and now I'm putting in angle 1. Here, I had the measure of angle 5, and now I'm putting in angle 3. So I have just proved that by substitution, my three interior angles sum to 180 degrees. All right, the corollary to the triangle sum theorem. So remember, my corollary should be slightly easier to prove. It's not quite as hard. And I'm given this right triangle ABC. So I'm going to call that given. Triangle ABC is a right triangle. Given. All right. Now, angle C, the measure of angle C is 90 degrees. Well, that's my right angle, and that's the definition of a right angle. If angle C is a right angle, which I know it is because of that box, then it should be 90 degrees. The measure of angle A, B, and C equal 180. Well, I just proved that right up above. That's my triangle sum theorem. That's telling me that the sum of the interior angles is 180 degrees. Now, if the sum of my interior angles is 180 degrees and C equals 90, I could actually substitute everywhere I see angle C, and I can put 90 degrees. So now I see that the measure of angle A plus the measure of angle B is equal to, plus 90 degrees is equal to 180. Now, I need to get A and B on a side by themselves, so I'm going to move this angle to the other side to be with its friend, 180 degrees. That was subtraction, just simple algebraic subtraction. So now I see that the measure of angle A plus the measure of angle B is 90 degrees. Well, that means A and B are complementary. That's the definition of complementary angles, that they sum to 90 degrees. All right, last proof. Prove the exterior angle theorem. Now this one is a little bit more difficult, so there's a hint. Find two equations involving the measure of angle ACB. So ACB, this angle right here, is going to be very important in solving this proof. So first, I know that the measure of angle ACB plus the measure of angle BCD equal 180. That's my linear pair postulate. They make a line, ACB and BCD are 180. Okay? So I said find two equations. That's your first equation. Okay? Equation number one. Okay, next. What are some other things I can use ACB for? Well, I know that the measure of this angle, A, and the measure of angle B, angle A and angle B, plus angle ACB, I know that when I add them together, I get 180. Triangle sum theorem. The sum of the interior angles of a triangle are 180 degrees. Okay? So I told you to come up with two equations, and that's equation number 2. So now I've got two equations dealing with ACB. Okay? So if you look here, here's ACB, here's ACB. And I've also got two equations that are equal to 180. So if something is equal to the same thing, that means you can set them equal to each other. So the measure of ABC plus the measure of BCD was equal to 180. But so was the measure of angle A plus the measure of angle B plus the measure of ACB. So I set those two equal to each other. It's transitive. This is equal to this. This is equal to this. Therefore, they're equal to each other. Okay, so now I'm trying to prove the exterior angle theorem. So try to think about where you're going. When we want to prove the exterior angle theorem, we are trying to prove that angle A plus angle B is going to give us that angle right there. If I add these two angles together, they're going to give me angle BCD. So if I look at this, here's BCD right here, and here's the sum of angle A and the sum of angle B, the sum of the measure of angle A and the measure of angle B. And the only thing that's in my way is this measure of ACB and measure of ACB. Well, if I use algebra, I can subtract it from both sides. Subtract that measure of angle ACB, and I'm left with BCD on one side and the measure of angle A plus the measure of angle B on the other side. Therefore, proving my exterior angles theorem. All right, make sure you understand these notes because we'll be using them in class tomorrow. And if you have any questions about the practice problems or the examples, make sure you ask me before we get started with our activity.